How has AI shifted the center of gravity of telecom networks? How can AI data centers keep up with the unpredictability of AI development? And why are networks so crucial to the development and adoption of AI tools? Welcome to Telegeography Explains the Internet, the show that explores the business behind all of the ways humans stay connected around the world. We are in our series on how the AI boom is impacting the telecom industry, and today we're going to dive into those questions and a lot more. I'm your host, Bryan, and my guest today is Phill Lawson-Shanks. He's the Chief Innovation Officer at Align Data Centers. With several decades of experience in digital infrastructure, Phill has seen the industry evolve from mainframes and green screens to the massive hyperscale cloud platforms we rely on today. In this episode, we're going to dive into the shift in data center geography and that center of gravity for networks moving towards these power-rich zones, and how the rise of AI is rewriting the rules of connectivity. We're going to look at engineering challenges in AI, from floor loading for 6,000-pound racks to the transition from air to liquid cooling. Phill explains the fungible design needed for modern AI factories. We'll look at the infrastructure bottleneck, why AI is ultimately a network-dependent technology, and how high-speed optical networking between buildings is pushing against the limits of physics. And of course, we'll talk about sustainability and power, how the industry is chasing power availability and pioneering new ways to build modern, efficient infrastructure. Phill also shares his philosophical take on the future of AGI and why he believes we're living through maybe the most exciting time in history. It's a fascinating look at the heavy physical infrastructure that makes our whole digital world possible. Of course, before we jump into the conversation, if you enjoy the show, please rate us, subscribe on your favorite platform, and tell a friend to listen. As always, you can find me on LinkedIn. Please share your suggestions and feedback. All right, let's get to it. Welcome to the show, Phill.
Thank you for having me.
Excellent. Yeah, I'm excited about this one. I've heard from some of my colleagues that you're great on these topics that we want to hit today. And first, I just want to get a background for my and the listeners' benefit on so where you come from, how you ended up as CIO at Align DC.
Certainly. Well, I was actually looking it up. This month is my 40th year in what we now term as digital infrastructure.
Wow.
So
all right. Yeah.
I cut my teeth back in the UK working for a company that owned and operated the airports in Britain. Each one of them had a mainframe. So I was selected to be part of a years-long training on all things technology. And part of that, I learned Fortran and COBOL and a quick build, which is an early 4GL language. I'm actually dyslexic, so writing code is not a great when you can't do your own editing. There's stories we can tell about that. But anyway, everything just clicked for me in terms of technology. And I came off that course. I was asked to drop and actually lead some activities on early local area networking work. So working with Novell and Banyan and Land Manager, Land Server, all those things. And that sort of struck me because we were using, it's all about workload. It's the job of work. So we're using mainframes because they're big computational power. Obviously, there was a time delay in getting the response. And if you put the wrong response in, you spelled it wrong in particular as a code level, it would be sketchy. But anyway, I saw that transition from green screens to big compute and specific business operations moving down to essentially a PC on its side under a desk. Initially sharing a printer. Laser printers were expensive in those days.
Yes.
Then there was some early file sharing. The advent of client server. So we actually had some more work utilizing the processors in the servers. And obviously that changed everything. I joined a compact computer. They brought me to the States and I did some things here. But again, it's looking at that workload. And we see those early elements of the internet as well, and how from those early BBS boards and things, just downloading drivers and some of those ICQ chats. The internet became a functional tool. And again, the applications changed, the software and hardware changed. and the location of those technologies changed. I mean, I used to have a sticker on one of my early Macs saying, the internet is just using someone else's computer.
Yes,
Or the cloud is the
I
actual.
have that coffee cup actually.
Yes, yeah.
Yeah.
So again, and we see that sort of transition from those early internet days, and obviously data centers. That's what we're talking about. How they became that hub and spoke, typically aligned with where the main interconnection points were. There was like 9 in the US, probably 7 or 8 across Europe, and there are key buildings in key cities all over the globe, and also the cable landing stations, which a lot of them trenched back into those buildings, or there were specific shoreline buildings and all of that. So looking at where that workload is and what you're trying to do, the reason I talk about this is, in the last few years, we've seen this enormous transition to cloud computing. COVID really accelerated that. If you look at just before COVID, I think it was something like March the 17th or something, we had 44 daily active users of Microsoft Teams. 19 days later, it was 78 million.
Right.
And the impact of that from the data center industry, it changed everything. The buy cycle of the cloud providers. And over the last few years, we've really optimized to service that cloud platform. We just took all the space. We draw down all the power we had contracts for, and that's an interesting that's we can talk about how that's impacted globally and society as well. Just the transition to electrification, our use of power, all of that. But during that ramp where the cloud companies, new ones emerged. Oracle just emerged as a cloud provider out of that, and typically we would go where the internet is or is going to be. You're coming from this space. We had a very good idea of where the internet physically is, those interconnection points, the tethers. Prior to my life at Aligned, I was one of the 4 that kicked off the data center business at EdgeConneX, and that was really looking at data flow because we were moving to social media. Not social media before even then, content distribution. And remember that spinning wheel of death with Netflix because it was hosted in 2 locations, but able to move that data to where it needs to be and transition how the internet is structured. That was amazing, and that's what brought me to here, looking at as that ramps up and the cooling and the sustainability. But anyway.
Yeah. Well, no, I think it's really fascinating because this is your personal history.
Yes.
But it aligns very well with how we at Telegeography are constantly talking about and thinking about the geography of the network and why the center of gravities have changed and why that's important. And ultimately here we're going to be talking about AI and how AI is further shifting that center of gravity. But I think it works out wonderfully that happens to be your sort of evolution in the industry.
Oh, it's funny. I was at Compaq during the HP merger. I left and came with a couple of us to fix WorldCom. That team had gone to jail.
Legendary Bernie Ebbers.
Exactly. Yes, exactly. They weren't there anymore. But there was a series of BMW doing a series of little vignettes and about the driver. And they had famous directors producing famous actors. And it was all around the driving experience. And I would sit and download those when I was living in Houston, and it could take about 15 minutes. Right. And I was commuting for the first couple of months. It was late one night, sitting in the old UNET building on Loudoun County Parkway in Ashburn. I thought, I'm in
Northern Virginia, so yeah.
Yes, exactly.
Yeah.
Yes. Yeah. So I downloaded it, and I went to get a coffee, and it was immediately there. And I thought, how is this possible? I really didn't understand how the internet worked. And so Vince Cerf was there, and I spoke to him and some others and said, teach me how this internet thing works. And after 2 days, well, actually it was a day and a half, I said, that's it, my brain I can't take any more. But it's all about the service and the distribution and use of that service. In fact, that was the ethos of when we created edge data centers. The edge was literally, it's the lowest latency point between a service and the consumption of the service. And depending on what those two things are, really dictates what you call edge.
Right.
So it might be content, it might be SharePoint, it might be Oracle, and it may be going to a set-top box or a handheld or whatever. And that was really how we viewed the world. It's moving workload and content. And over the last several years, with cloud's tremendous growth, we've really optimized for that. And we've seen emerging zones where new internet had to be trenched to it, and then it becomes a point of presence, and things sort of sprout around that to get that on ramp. And as a company, we've been land banking, as I say, for many years, knowing where the internet is or is going to be, and then working with our hyperscale clients and saying, where are you thinking of going next? We have all of this in our portfolio, and then we'd
Right.
execute and so on. Now, again, this has changed again in the last 2 years with AI, because that's a very different workload. What we've seen up until this point, well, up until maybe several months ago, where it was the large foundational models, and it didn't really matter where those were, to be honest. The latency wasn't an issue. So new cable has been trenched to places where there's a lot of power and land to do that. And as
Yeah.
we've used those technology platforms to start interacting with the inference, and we're getting the mixture of experts and the small language models, as that inference starts moving towards the edge again, we're seeing this other flow. So large language still doing lots of computation, but actual use cases of agentic workloads, again, at the edge or proximity to users and their data. So in all these things, the internet is fundamental.
Right.
It's extraordinary. And I did a lot of work in previous worlds with cellular and 5G. But you still need, even with satellite, you still need a ground station. You still need terrestrial data paths to connect all of these things together. So anyway, so my history has been, I've seen this grow, but in my mind, it's always about the workload. What are you trying to do? Because that really you derive everything from that, whether it's the software abstraction, the chips that run that technology, the box that sits in the frame, the rack, the location of the building. Everything is driven by what you're trying to do.
I was going to say, this is the challenge in thinking about, everyone wants to know from us what's the impact of AI on the network. And the answer is it really depends on what AI ends up being, especially for the enterprise, for the consumer, that sort of thing. If it's LLMs, something like that, that's a very different story, because the amount of bandwidth there isn't that huge. The latency isn't necessarily going to be as crucial. If it's something a lot more involved, like sort of video based or whatever that might look like, then it's a very different story, right? And I don't know that's clear yet. So
No, it truly is an event horizon, and we talk that because we can't see beyond it.
Right.
It's that. So yeah, as a business, we're trying to. We've always focused on sustainability and adaptability. But there's a certain fungibility you need to bring to design and deployment criteria. This is very akin to the first industrial revolution, where we migrated from physical power to mechanical power. And as those engines, those steam-driven engines, were looking for a location, we had a lot of warehouses, so they naturally went into that, and they
Right.
became the cities and everything. And then
Brownfield development is always easier in any evolution,
exactly,
right? So
yeah.
yeah.
And then there was a certain metric that triggered, and then they built their own factories and so on. And that's where we are. We've utilized nearly all the space. I think there's only 3% vacancy rate in the US right now, and it's not useful 3%. It's sort of pockets. There's not really contiguous space.
Right.
So we've used all that up for the GPUs, LPUs, XPUs, TPUs, XPUs. And cloud is still growing. We need a lot of cloud as well to make this work. So we're seeing that there's a bifurcation in how we design for this. And again, it's essential that we understand the job of work and where we can put these things for power and for network.
Right.
Because as you say, right now, most of it's text-based, and we'll tolerate some latency. We'll wait for it to come back. But when we start being much more interactive with the world, where there's more augmentation, there's more immediate interactions with maybe agents that sit on your iPhone that are tethered to an eyepiece headset.
Literal digital twins. I've seen people who have sort of made a digital twin of themselves to answer frequent questions, things like that, right?
Exactly.
So, yeah.
So latency is going to be really important again. And we have 5Gs out there. There's talk of extra technologies that are coming. Again, they all have to go back to a data center or an on-ramp to the network of some description. So
let me ask you this then, to give you a chance to sort of go directly here. So that what is it that is unique about Aligned compared to, within the industry, there's a lot of other sort of more household name data center operators or developers. What is your vision of the world that's different than some of those others?
Oh, sure. It's actually when I got here 8 years ago, I came because of the cooling technology, to be honest.
Hmm. Hmm.
Um, the last building that I was involved in other companies, it was for a hyperscaler. We look at these things and they're always cooling bound. We used a technology with these big boxes that sat around the periphery of the data hall, computer room air handlers. And they were expensive, significantly so. So they were baked into the depreciation cost of the building,
Hmm.
which was fine when technology churn was like 8 years, where
Right.
there's
Right.
always
Yeah.
iterations with
Yeah.
CPUs, but it has to be a significant amount before a hyperscaler or someone will say, okay, I've depreciated the cost. I'm now going to go to the next thing.
Right.
So I'm going to need a different power envelope or thermal envelope. But that was happening at a tremendous rate. So looking at cooling technologies, that's what brought me to Aligned with the Delta Cube array,
Hmm.
air handling, 50 kilowatts a cabinet. So in basic terms, in traditional cooling, you'd have to spread out the load because airflow dynamics, you have the hot stuff in the middle, progressively less power at the edges. So you spread out a megawatt over 16 rows of 16 cabinets. So a lot of empty space, a lot of additional carbon in that, lots of cabinets, top of rack switches, cabling, whereas Aligned would do that in 20 cabinets.
Hmm.
So
Hmm.
the hyperscalers loved that. And we just ramped on that. But it was all about sustainability, lower carbon footprint, designing differently so that our customers could adapt as they go. And then a couple of years ago, we devised our own liquid cooling systems. It was coming. We do a lot of work
Hmm.
with the GPU companies. There were great products on the market, but it didn't fit our profile and our footprint. We wanted to be able to drop them in because we know there's going to be a blend going forwards.
Right.
And there's going to be either, and even now, there's a lot of our clients, they want 70% liquid, 40% cooling. So you over provision on both. Some want
Hmm.
90% liquid and
Mm.
30% air.
Right.
So um, having that ability to be fungible is
Right.
important. So, and
Yeah.
that's something that Aligned has always really lent into how we design. We design in a modular fashion, not modular containers, but modular key components. So they're
Mm.
faster to build, built in a factory environment, less
Mhm.
waste, less risk of any geological local contaminants of bits of metal falling on the ground and getting into the aquifers and water supplies. But that ability to just transition in flight,
Right.
which is increasingly important as our clients, many of which are highly aligned with the GPU companies, would say, we have a contract with you. We've taken the whole building. We're really happy with the delivery timeframe. But by the way, we're going to take the next form of chips, and we need
Right.
an entirely different thermal and
Yeah.
power
To your
envelope.
earlier point, that development cycle is so much faster, and it's
Exactly.
only getting faster. So yeah,
Exactly. We're having
absolutely.
it midstream now.
Hmm.
But again, we have the ability to be fungible and move things
Hmm.
around. So and
You,
that's one of the pillars of Aligned. Its ability to adapt to the
mhm.
demand.
Yeah, well, I want to put a pin in the sustainability point that obviously, sustainability is something that is desirable, within the market, and to tout that, but in economically more feasible in many cases. And now we're seeing, data centers used to chase power costs.
Hmm.
Now they're chasing power availability at all, right?
Yes,
Like
it's
just
true.
just even the ability to get, when we have megawatt data centers planned and whatnot. Um, but at telegeography, what we're always thinking about is you mentioned earlier, digging trenches, right? Like tying that back to the network. That's what makes any of this useful. Something I've said on the show pretty often is that, if you go back in time and think how humans have been thinking about artificial intelligence
Mm.
for a long time in science fiction and whatnot, it was always a computer. Like 2001, HAL is a standalone mainframe computer. That is not how it developed. AI
No.
is absolutely a network, and it could
Oh,
not exist
absolutely.
other than as a network. So when you're thinking about that sustainability piece, at what and there's all kinds of other factors, water availability now, the community involvement, those kinds of things, then you say, okay, well, this is a good place for a data center, then how does the network become part of that conversation,
Mm.
right?
Yeah, well, as I say, we used to build land bank where the internet was going to be. Now, as you say, we're going to where there's power.
Right.
And even though it's not inexpensive to trench new fiber or do aerial or whichever way, it's more cost effective to do that than to do
Figure
high
out the
tension
power.
lines. Yes.
Right.
And even then, when we build, we build our own substations. We furnish that ourselves. We effectively gift that to the utility to operate. We pay for all the interconnection, all of that, and pre-buy the power. We've done that for years, and all our power is green. It's all sustainable power, always has been. But yeah, it's the internet is changing much faster in this world because there are several companies that specialized in dark fiber and tranching and all of that, and everyone, there's the different tiers of internet providers, the tier ones and twos and threes, and there were certain pathways, historically, whether a pipeline or a train track or, a right away from a telegraph line. There were key lines, and that's changing really, really quickly. Obviously, they're to be tethered off of those main trunks, but we're seeing the emergence of new zones. I mean, availability zones, that's really an AWS term, but it's applicable. New hyperscalers are saying, there's power there, I'll build there. And then the internet comes to them. And then all of a sudden, that becomes a hub where other services will want to be built. You just need one anchor tenant of significant size, which will draw the internet. And if there's, again, sufficient power, then you'll have a new availability zone sort of sprawling. One, whether it's a Meta, then Google and Amazon come, or whether it's Amazon, then Oracle, and the internet is really much more dynamic now than it ever has been, which is fascinating to see as sort of an organism growing.
Yeah, well, I mean that's a good point. It has evolved. It when you think about just the entire evolution of the internet, it has ultimately been anarchic, right?
Yes.
Yes, there were you sort of alluded to, but didn't name, like May East, for example, when you met Vint Cerf back in the day, and that sort of thing. There were some, sort of quasi-governmental aspects to things and whatnot, but ultimately this was just people developing things as needed when they saw that need, and I think that's very much still the moment that we're in and will be, right? So
I
yeah,
think so.
I'm sure you know from your travels in the industry, Hunter Newby. I had him on this
Yeah.
series earlier, and he wanted to drive home a point that I'd like to get your sort of take on, since you brought this up, of there should be within the industry a more clear distinction between data center and colo. So as you're developing something that's made to house GPUs for the purpose of inferencing and things like that, right? Then we have to build fiber to that, and then it has to join into the internet ecosystem, which geographically may be difficult. And then we too often conflate these two things, data center and colo, when they're really serving different purposes for the stage that you are in that connectivity, right? So,
Absolutely. I mean, the term now, I think it was Jensen Wong coined it, or probably someone else did, but I mean, AI factory. I don't think I really like that term, but that's the term.
Yeah,
So, and
we have to stick with it now.
exactly, it's out there, and we have a solution for that. So we have a very prescriptive build that's optimized for minimum material, maximum sustainability. All of those amazing. We're part of Green Globes or GBI, the Green Build Initiative. So we follow that methodology. And also we were one of the pioneers in embodied carbon traceability. So we helped form the Climate Accord with iMasons and all that, really just to ensure that we're buying the right materials and doing it properly, and being able to report on that, and our clients can do that. So in all those things, we have that traditional build methodology, but we're having to rethink that because of this technological churn. And also, they're not really racks anymore. These are containers of compute modules. Now with the double wide that we're seeing, and we're part of OCP, Open Compute Project. We help define some of those, the liquid rack, the liquid in the halls, all of that. We've the hyperscale certification for data centers. But you have to now think differently, because even just basic things like the floor loading, a typical data center is designed for £3,000 per square foot, rolling static weight. these racks are coming in now typically about £6,000.
Wow.
We're
Yeah. See,
looking at
these are things that people would not think about, right?
no,
Like new
exactly.
challenges. Yeah.
Yeah. So
Yeah.
the legacy buildings, you even if they had the power and the cooling profile, the floor tiles probably couldn't take this.
Right.
So
Interesting.
we build on slab because of our cooling. We don't need floor tiles, but all of these angles of approach, these are now robotic tugs removing them from the trucks and
Hmm.
positioning them into space into the final location. So you have to take all that into account.
Right.
And we're seeing, we had, from a cloud perspective, we had these campus sort of mentalities where it just made sense.
Hmm.
Now we're seeing that with AI factories because, the way AI works, if anyone can actually truly see how it works, because it's still a bit of a black box.
Right.
We don't need to go down that path.
I was going to say that's a scary topic for some other time over
Yes,
beer.
yeah.
It's
But
yeah.
but the
Yeah.
current way we do it, and it's very typical of how in the West we've always thought about software. You have the next version, you need more horsepower to make it work. So
Hmm.
you get the next iPhone, you get the next Mac, the next
Right.
HP notebook or whatever, a next server. So as we start to improve performance, we need more GPUs connected in close proximity. Every GPU has to be connected to every other GPU. That's how it works.
Right. Right.
So having campuses of those now and having the ability to have high speed optical networking between buildings, which we're still building that out. That's still, I mean, physics gets in the way. Physics is very
Hmm.
annoying. It does limit a lot of what
Yeah.
we want to do.
Yeah. Yeah.
But it's, the optical nature of going to the chip directly. This is an incredible time in human history. But what we're
Yeah.
seeing is more buildings being closely coupled together to act as a single entity to deliver on these services that we're pulling from. And then those will be closely coupled with cloud data centers to actually deliver the data that these tools are going to be using. So,
That is
and
really
that's,
interesting.
yeah,
Going back to how you started. Looking at, okay, we have mainframes, and then we start to have a PC under the desk, and so the world of networking was about the LAN in the corporate environment, and then we get to the WAN and long haul and spreading that across the globe, and now we're sort of pulling back to a data center LAN, if you will, right? So
yes.
that intra data center network has really sort of come center stage again, and I know I've focused on the globe here, right? You know what I
Yeah.
mean? So I know just enough to make me dangerous in moving away from InfiniBand and Ethernet and all that. Yeah. So like, sorry to interrupt, but I just wanted to put a pin on that of like, to make sure we get your take on on how important that is and what we're seeing advance
Oh,
there, right?
it's absolutely vital. It couldn't be more important, and just how that works. They all have to be connected, and finding new ways. I mean, we've seen the evolution of just the internet, where we went to DWDM. We did
Hmm.
multiple lasers at different frequency rates. Now we're seeing that within the InfiniBand type architecture. It's
Right.
not just a single point. And what's fascinating is actually copper works faster than fiber just because of the
Interesting.
electron
Because the
flow.
short spans
Exactly.
too.
Well,
So
even
yeah.
yeah,
Mhm.
and as long as you don't go beyond that certain resistance list,
Right.
the data transfer or the effective transfer of copper is, was it 78% the speed of light, whereas optical fiber, because it's refracting on the inside of the tube
Mm-hmm.
of light, it's about 68% the speed of light, but it goes further and you get
Right.
less data loss. So, and it's all these things that are coming to play. Um, Again, it's all about network. You have amazing chip technologies, and we're seeing some of that being spread even in NVIDIA's new DSX architecture, where they need to increase their memory and their tertiary memory. So they got high speed fiber networks to another pod of just storage servers
Hmm.
just to feed the data. And then you'll start seeing multiple of those connected. Again, all of this goes back to the network. I know that's
Hmm.
the essence of
Yeah.
this. And
Yeah.
that's
Yeah.
my background
Absolutely.
as well from
Yeah.
early days when I was hand crimping coax cable for
Yeah.
RG6 and RG5 and whatever. But you can't stress or can't overstress the importance of the network, whether in the data center, between the data centers, the consumers, and we're not
Hmm.
even talking about as we get to true AI, IoT in factory environments, how those start having to be connected back in multiple myriad fashions to secure cloud and secure AI instances for
Right.
data sovereignty. And it's, I could talk about this for days, clearly.
Yeah.
Get very
Yeah.
boring at
Yeah.
dinner parties.
Yeah, no, well, I mean, it depends on which ones, right? So
Oh, that's true. That's true.
at ours, yeah, yeah, absolutely, yeah. And going back to something I said kind of at the start, is that's where the difficulty of our position in this moment is right now, is that it's Ray Kurzweil kind of idea that there's a singularity that we have not yet peered through to the other side,
Yes.
and that really is going to determine like what that network looks like. I mean, you can wax philosophical about just ubiquitous network everywhere, and we have now the Leo market and
Yes. Yeah.
6G and things that will facilitate that. But even that, right? Every single landing station or cell tower still has to have wires connected to it, and it has to go
Absolutely.
back to a data center that has the appropriate distance and compute there for whatever those activities are, whether it's driverless cars that need constant information, or smart cities, that sort of thing. Like ultimately that is all about data center, and I think really data center geography, right? So like
Yes.
what is the right
Absolutely.
size data center in the right location? You've touched on this a lot already, but just to drive that home, what's your vision there from Aligned?
So we're very focused on the cloud architectures that are that's still growing tremendously, and also serving this I wouldn't say unknown, but uncertain future for what an AI factory is going to look like.
Mm-hmm.
Because the technology is changing so rapidly. As I say, rack sizes are changing. The power. We're having to design for buildings that have been traditionally AC current. We're designing. That's coming out now, knowing that DC current is coming,
Mm-hmm.
which is
Mm-hmm.
an entirely different structure. Simpler in some aspects, but some of we're still building out some of the core safety components and
Right.
infrastructure to make that happen. But again, knowing that that's coming, and where they're going to be to serve whatever purpose. But again, I think it always goes back to what is the job you're trying to do? What is the load?
Right.
And that will
Right.
dictate the size and location.
Mm-hmm.
But I mean, just extraordinary thing. And just if you read what Apple have done quietly, even with the iPhone, their integration of their AI chip in and the memory bus modules, that's capable of a lot more than we're using for today. But that's got to then be tethered back to data centers. I mean, you'll have a lot of processing there, which we have already, but it's
Mm-hmm.
going to be pulling back from more traditional AI or data center, colo data centers, cloud data centers to pull its data. So highly connected in every conceivable way. And you touched on Leo. That's going to be really interesting when we get better, if we can even get high speed bidirectional flow data transfer.
Right.
That's
That's key.
comparable to
Bidirectional is
5G.
the key there, right? Yeah,
Yes. Yeah.
absolutely. Yeah.
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 And I'm not sure about data centers in space, honestly, because there is a cooling element there. I mean,
Mm.
it doesn't, you can't dissipate heat in a vacuum. I mean, a vacuum is
Right.
essentially an insulation.
There's nowhere to go.
So
Right. Yeah. Yeah.
we don't need to go down that path.
Yeah.
But
Yeah.
we're seeing technology being deployed in places we've never thought of before, all
Mm-hmm.
highly connected and to serve the purpose that they're being deployed for. This is for me, this is one of the most exciting times that I can think of in human
It
history.
is. It is, I think, because you and I are both involved ultimately in a heavy infrastructure industry, right?
Yes.
Whereas the public consumes this as applications and fancy new tools that enhance their lives. The ultimate bottleneck for all of it is physical heavy infrastructure, right?
Yes. Yes.
And even to the extent that that we're speculating on like what will AI actually look like, I think there is this recursive relationship where we've been saying, okay, well, what the network is going to look like depends on what AI ends up being.
Hmm.
But what AI ends up being depends on the network, right?
Exactly. Yeah. It is
Yeah.
recursive, as you say. Yeah. Yeah.
Yeah. So I think that our industry gets in the news really in a couple of ways these days. It's data center boom, and when there's a submarine cable fault somewhere, right? You know
Yes.
what I
Yeah.
mean? But there's a much more almost interesting story there in the way that the real way to develop has to involve this infrastructure that whatever Sam Altman or whoever can come up with, right, can push in those directions, that is ultimately limited by their ability to do training in the right place,
Yes,
and their ability to push
absolutely.
that to an inferencing GPU in the right place, right? So yeah,
Yeah, exactly. And our ability to interrogate it or utilize it.
right, right,
Exactly.
right,
I mean,
exactly.
it's really interesting. Even in the last few months, as Claude has come out and OpenClaw and all those things, um, it's really changed the conversation. And
Hmm.
um, yeah, it's just an extraordinary. And internally, we've been using AI tools for productivity
Hmm.
um,
Hmm.
and maintaining some of our technologies and things like that. And it's extraordinary. It's extraordinary.
No, that's a little far afield for telegeography explains the internet, but a topic that I'm personally like really interested in, and one of the things, since I have access to a lot of these people, right? I love to ask folks further up the stack than what we do, right? What is AGI?
Yes. Yeah.
I don't think I've heard a clear answer from
Oh,
anybody. You know what I mean?
well,
Yeah. So,
that's the trouble. Yeah, we
yeah,
don't fully
would we know
understand.
it when we saw it, right?
Well, yeah,
So,
exactly. I mean,
yeah.
the thing, we don't fully understand our own consciousness. We don't
Hmm.
understand. I mean, you can look at the mechanics of how, neurons fire and we have memory
Right.
and all of that.
Hmm.
But truly, what, how, because we're part of the system, you can't really step outside and look at the system.
Right.
It's that whole
Evaluating itself. Right.
dimensionality.
Right.
Yes. If
Hmm.
you're, we're a three-dimensional world. If you would look at a four-dimensional thing, it would be very different.
Hmm.
So it's really hard to actually say what is consciousness. We know it when we
Right.
see it, or at least we feel on a kinship.
Hmm.
And AI is really just pattern recognition, but it does it extraordinarily well
Right.
and can find patterns that we wouldn't have thought of. So as
Yeah,
that gets
no,
better
that's
and better,
exactly it. We blew past the Turing test, ended up being
oh
not very
yes,
useful at all
no, true,
because we ran into this problem of like, each of us believes that we're conscious but can't really interrogate the consciousness of anything else, right?
exactly,
There
exactly,
is something that it is to be like all kinds of things, maybe all the way down to molecules, but we can't interrogate it at all, right? So
no,
it's like,
no, exactly.
yeah, yeah. So
So it's hard to say if we'll get there, when we'll get there, and would we know it when we saw it.
right, exactly, exactly.
So
But I think your point is a good one, which is that what ultimately the result of that is what does it do for us, right?
yes,
You know what I mean? So,
yes,
and again, that what does it do for us, I think is very much going to drive the conversation of like how does it need to be connected to the other units of whatever, right?
yeah,
So, yeah,
yeah,
absolutely. So. Maybe this is too big a question to bite onto, but since we're getting close to time, I'll push you in this direction, right? Which is how do you, as a data center infrastructure provider, plan for this, right? That even just the next 6 months might be sort of unknown. How are you looking forward to say, okay, well, these are the directions that you're. It's in your title. You're the chief innovation
yeah.
officer, right? So how do you plan for something that's sort of unknown now, right?
Yeah, that's a great question, and in that planning, we have to make sure that we maintain our integrity of our
Hmm.
core DNA in doing
Right.
things as sustainably as possible. But it goes back, as I said, it's that fungibility. It's designing for
Mm. Hmm.
uncertainty.
Hmm.
There are key, I mean, and obviously in any industry, you do things, you build upon layers. Everything, there's something you've built or done or process, and you build upon that and you build upon that. But often takes a point where you step back and say, well, we're hitting we're slowing down a bit. Was that the right thing in the first place? Let's go back and revisit that.
Hmm.
And we did that with how we design our buildings,
Hmm.
quite fundamentally, how we can accelerate the process by doing things entirely differently. And as a company, what's been very interesting, we've grown tremendously from 30, 40 people when I joined in 2018 to, just shy of 2,000 now in
Wow.
that
Yeah.
time frame. Um, we're hiring from other disciplines to get a
Mm.
diversity of thought,
Hmm.
and they challenge. Well, of course it's that way. We've always done it that way. Well, why have you done it that way? And so that informs us in. It basically breaks our arrogance of, well, because we've been doing this. We've been doing this a long time. So
Hmm.
it's constantly going back and revisiting. Is there a better way of doing this? Best idea wins.
Right.
And working very closely with the chip manufacturers and the memory companies, the ODMs that are building the servers, understanding what they're trying to do, and the software layer to see, because then it's recursive. So the software progresses based on the capacity of the hardware it's running on.
Hmm.
They see a market, so they build an adjacency or high performance hardware that gets better. That has dramatic implications in how you build a building to support that.
All right.
So being tightly coupled with that flow to say, if it's cloud, we've got that. We know how to do cloud all day, and we can build the best, fastest, most sustainable cloud data center on the planet, I would say. But this new breed for this entirely unknown endpoint,
Mm-hmm.
if we look at just NVIDIA's chart of their forward forecast, Vera Rubin is very different. Feynman is incredibly different. And
Mm-hmm.
that drives everything. The software is going to be different on top. The thermal load is going to be different. The network's going to be different. But also the box it comes in is different. And we need to build for that. So what we're building today, we know that our clients are going to want that in 2 or 3 years. So
Mm-hmm.
we have to give them that easy access, that upgradability to that. So in all these things, that's where we spend a lot of our time, and looking at the right materials and building methodologies, and using tools that enable us to slimline our supply chain or our construction partners, how we can work with them to ensure that we're doing things as efficiently and as open as possible. Having that open conversation with the client so they know what we know what our GCs know, we know what our supply chain knows. Having all of that and working within that knowledge base, which it's so interconnected and complex, we have to use these new tools to even make sense of that sometimes,
Right.
so we can
Right.
have that relationship.
Yeah, no, those are great points. And again, one of my goals on the podcast here is to get people in the telecom industry to think broadly about how this whole ecosystem works together. And sometimes that means thinking about what's coming out of Corning or Prismian or whatever, you know
Absolutely.
what I mean? Because there's a lot of innovation in those spaces that's going to have a major impact on the network, on data centers, and
Oh
staying
yeah,
on top of that is difficult, I imagine. Right. So
yeah.
yeah.
That their new hollow fiber tubes. Just
Hmm.
looking at different ways of moving more data faster,
Hmm.
because that is all about, it's the interaction of all these things together.
Right.
Absolutely.
Yeah, and it's been interesting because you mentioned earlier that so you bump up against physics sometimes. There is, of course, like the Shannon limit and things like that. But even still, we've still kept moving faster than Moore's law with
Yes.
data transmission for decades now, and it's it probably to the consternation of some of the telcos, but
I would think so. Yeah.
yeah, yeah, but yeah, it's I think really to your point of like keeping flexible and modular with the way that you envision things so that you can move quickly when things change, because they will,
Yes,
right?
it
So
has to be. And on
yeah.
talking about law, so Metcalfe's law, I mean, you couldn't have a more perfect analogy or description in a GPU cluster. I
Hmm.
mean, that's
Hmm.
entirely,
Hmm.
the more components, the faster. But anyway, but yeah, this, also, these aren't, there are very few new things that are coming. There are new ways of doing it. There are some interesting very interesting new technologies,
Hmm.
but there's, we just have to keep going back and revisiting, was that right? Can we pivot? Can we change that
Right.
midstream?
Yeah.
Because we're in a constantly evolving world.
Hmm. Well, and since we're bringing up, laws and things like that, there's also Javon's paradox, right? With
Exactly.
of
Oh,
that, the more efficient everything is, we're
yes.
just, and this is really, I think, going to apply to AI, where consumption
Yes.
is just going to go through the roof when it is at the right time, right? So yeah,
No,
absolutely.
I agree. It is fascinating. It's the most exciting time to be alive, I think. But then
Yeah.
I'm a nerd and I love all this.
Yeah.
This is what
Yeah, yeah, absolutely. Yeah. So, well, Phill, this has been really fascinating conversation. I appreciate your insights from the industry and of the more sort of philosophical variety. Um, just to close us out, what do you think is maybe most important for your focus for the rest of 2026 here?
I think it's more of what I said. It's trying to
Hmm.
anticipate. Well, so in my the way I look at the world, I'm trying to anticipate how society is going to use technology, how technology
Hmm.
serves that, and then how we can deliver the engines underneath that to make that happen. So as we see new adoptions or new ways of doing things, that's where I'm trying to get to. But
that's a tough job.
It is.
I wish you the best.
No, but that's
Yeah.
I don't watch soccer. I don't watch football, and so that's what I mean, that's a very nerdy thing. But again, it's all about delivery to meet this incredible, insatiable demand for these services.
Yeah, exactly. That's what I was saying before, that sustainability is something that's better for the industry, let alone society in general, right? So
Yes.
yeah, absolutely.
Yeah.
Yeah. No, that's, and I should say likewise for me, when folks bring up sports, my eyes glaze over, and then I go home and listen to a podcast about neuroscience and technology. Yes. And so there has to be those of us in the industry thinking about these things, I guess. Right?
I guess so.
Yeah,
we don't get invited back much, but there we are. I'm okay with that.
Yeah. It's all about the right audience. So you're definitely with like-minded people here on this.
This is my tribe.
So,
we're in the same
exactly.
tribe. Yeah.
Excellent, Phill. Well, thank you so much. This has been a lot of fun. If folks want to keep up with you and what you're up to, how can they find you best?
The best way is to go to LinkedIn. I'm on LinkedIn. You find me very easily. I'm involved in a lot of things. I sit on a couple of different boards, do a lot of work in the education space. Know my future is to help this new, we lose, for every 5 people we lose in the industry, we're only getting 2. So bringing new blood in.
Great point.
I'm on the board of GBI, looking at how we build better. There are lots of things. But just reach out on LinkedIn. I'll get back to you.
Yeah. I ask all my guests that question years ago. Some of them would have a Twitter handle or a blog or something. It's all LinkedIn now. So apparently they won. Yeah. So, excellent. All right. Well, thank you so much, Phill. It was great fun.
Thank you so much. Appreciate it.
Thanks for listening. Telegeography Explains the Internet comes from the experts here at Telegeography. It's edited and produced by Jane Miller, and it's hosted by me, Bryan. And I also wrote that theme song you're listening to right now. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.